Welcome to the fastest way to learn data structures and algorithms with this premium revision material. Today, we are mastering LeetCode 205. Isomorphic strings. This is a fundamental string problem that tests your understanding of mapping and character relationships. Let us look at the problem statement. Our task is to determine if two strings, S and T, are isomorphic. But what does that actually mean? Two strings are isomorphic if the characters in S can be replaced to get T, while preserving the order of characters. There is a critical rule: every character in S must map to exactly one character in T, and no two characters can map to the same one. It is a perfect one-to-one relationship. Think of it like a secret agent's substitution cipher. Each letter in the alphabet has exactly one partner in the secret code. If you find that the letter A is sometimes replaced by X and other times by Y, the code is broken. And if both A and B are replaced by X, you will not know how to decode it back. A valid isomorphic relationship is a perfectly synchronized set of secret code rings. For our strategy, we used the dual hash map approach. By tracking the mapping in both directions, we ensure that every character has a unique, exclusive partner. This prevents the many-to-one or one-to-many traps that would break the isomorphism. Let us dive into the dry run. Look at the screen. We have our source string S. Paper, at the top, and our target string T. Title, at the bottom. We will use two maps to track these relationships. First, we look at index 0. S has P and T has T. We check our maps, no mapping exists yet. So, we create a link, P maps to T, and T maps back to P. Everything looks good. Next, index 1. A in S and I in T. Again, no existing mapping. We create the link, A maps to I, and I maps to A. Now, index 2. P and T. We check our map, and P already maps to T. In T, T also maps back to P. This is consistent. We move on. Index 3. E and L. New characters, so we map E to L, and L to E. Finally, index 4. R and E. No conflicts. R maps to E, and E maps to R. We have reached the end with no broken rules. So, these strings are isomorphic. Result, true. Now, let us look at the Python code. We initialize two empty dictionaries, S to T, and T to S. We iterate through both strings simultaneously using the zip function. For each pair of characters, C1 and C2, we check if a mapping already exists. If C1 is already in our map but points to something other than C2. Or if C2 is in our map but points to something other than C1, we have a conflict. We immediately return false. Otherwise, we update both maps and keep moving. If we finish the loop, we return true. Looking at the complexity, the time complexity is O of n, where n is the length of the strings. We traverse the strings exactly once. The space complexity? It is O of k, where k is the size of the character set, which is usually constant. We only store mappings for the unique characters we encounter. And that is isomorphic strings, mastered. Save this video for your next technical interview, and follow Leo Academy for more such premium DSA guides.